Alright, we continue our lab. So we have stopped this at wall. So okay, this one is already setting, and then we continue to glass. So for glass, you can refer here. Glass of window using clear glass with shade. Assume shading coefficient is clear 3/32 dash 3/16" thickness with medium blinds. Okay, and then so setting at glass here, clear glass. This one, clear glass. So you need to use this with shade. So yes lah, because your lab sheet mention with shade. So clear window shade is yes. Right. And then this one in summer, and then at winter. So also press the same setting, clear yes. And then shading coefficient is 3/32. Okay, this one. Twins 1. And then internal shading device is used. So number 1. The internal shading coefficient is from lab sheet mentioned with medium blinds. So this one clear medium blinds with thickness same as your lab sheet. Alright, so 0.81, 0.83, 1, 1, 0.64. Okay, 5.8 as LTD glass definition. Okay, RTS is ignore, okay. So continue at partition. So this area of partition, you can only use if this one actually you need to input the temperature, TD, temperature different for cooling and heating lah. Temperature different in degrees, in degree Fahrenheit. Across the partition for the case where the unconditioned side for the partition is at its hottest. So let's say you have the temperature difference between room A and room B. Okay, let's say your room A, okay, let's say here, contoh. Okay, from your layout. Okay, this one is all room is conditioned space. Okay, let's say room 1 and room 2 is conditioned space, but room 2 is no air conditioning. So this kind of situation, you need to input the partition because you have a temperature difference between room 1 to room 2 and room 2 to room 3. Okay, so for this condition, is all is conditioned space. So nothing to do with partition lah, so just ignore. And also ignore shading. Okay, so we do to the next portion is A handler data. Okay, this one just minimize. So for A handler data, A handling unit lah. So number 1, because for single story we only use, assume we only use one AHU unit lah. So number is 1, number AHU. So name is, let's say we can do it AHU number 1. Okay, issue number 1. So for main system type, just maintain at constant volume. This one is default setting lah. Again, supply fan time is draw through fan. Okay, so for general, so occurrence of this A handler, you need to compulsory to input 1. Okay. So this one you can refer lah, the usual value to enter into this field is 1. So which indicate that the air handler and the rooms within the air system are active. Okay. So if you put you forgot to okay, let's say you forgot to put this occurrence of this handler is okay, let's say you put 0. So the report that you generate from this software is not include the air handling unit calculation. So the data is wrong actually. So we need to input number 1. Again, for so basically you know, so inside your air handling unit you have a heating coil and also cooling coil. So you need to setting the temperature of living. Press here, living heater coil temperature. This one you need to remember lah for your lab test. So living heating coil temperature is 95 and living dry bulb temperature is 55. This one I didn't give you in the lab test. You need to remember this. So leaving heating core temperature and leaving dry bulb temperature. Okay, next for fan efficiency, so by right your ASU using a fan lah. So fan. So you need to find it here. Okay. So where's about the fan? Okay, here. Take motor efficiency 65% and static pressure across the fan is 2.2. So your fan motor efficiency is 65, your input here, and static pressure is 2.2. Okay, settle for main area. So this one is default default setting. This one compulsory to put. So 1, 1 point, 2 point, 3, 4, 5 point at main. So we jump to general. So general. So you can, okay, based on this profile, people. So the number one here basically is you are setting from G. G. So operating profile default people is 1. So because you put 1, so that's when the 1 number here is appear. So you just you can leave it 0 because it's default to 1 actually. So you can also put 1 because the same result will appear lah. So either you put 1 or you put 0 is okay. Okay, because the report generated here after this is come to 1 lah because we are setting at general project data before this. Okay. So this one all is leave it here like this. So calculation option default to calculation specified in general project data. Okay, this one that I mentioned before lah. So the number 1 here setting automatically appear 1 because from general project data. So next we jump to the infiltration and ventilation. So refer from your lab sheet. For your cooling ventilation is 5 CFM per person. So just input click CFM per person and input 5 here. And your infiltration cooling is 0.5. ACH is a change per hour. So this one cooling infiltration just input 0.5. Okay, this one just ignore it fainting because you're doing at molecular site. So only cooling. Okay, next. Okay, 2 point only here, 5 and 0.5. And next is indoor condition. So how much the dry bulb temperature and also how much the relative humidity of your country based on your January month lah. So you can refer this 75 and also this one is 50. So the number appear here 75 and 50 based on the indoor and outdoor design condition. Okay, here because you're setting Melaka, right? Okay. So next setting in the condition and miscellaneous. Continue at miscellaneous. Just input the summarize only supply. Okay. So either your duct is insulated or not. So you can refer this lab sheet. Ducting. Duct is insulated. Okay, this one ducting type for main trunk is using rigid ducting with insulated. So duct is insulated, yes. So so basically they have two options here, either low or high. So I forgot to put here. We need to take low or high. So ducting type of main trunk is rigid ducting with insulated in bracket low. So you need to put here. Choose this one, yes, low. Okay, and also return. Yes, low. So 1 and 0.25. Okay. So only these two parameter we need to setting. Okay, then continue duct sizing. Okay. So you want to calculate the main trunk and run out. Run out is basically is main trunk. Let's say you already know main trunk is rectangular shape. Run out is this one is we call is branch duct. Run out is branch duct. So you need to calculate or not. So need to press yes, yes, here, yes, here. Use schedule is yes, both is yes. And then continue rough factor. Rough factor, your main trunk material is fiberglass ductboard. So choose fiberglass ductboard. And run outs. Run out is branch duct. Normally we use flexible duct. Okay. There's no mention here about the flexible, but you need to know run out is a branch duct. So branch duct is used flexible ducting. Okay. Then continue pressure drop. Pressure drop, okay, 0.1. Because you already set the fiberglass duct, so the rough factor, run factor is 0.003. So there's only setting here. Pressure drop is 0.1. Also pressure drop is 0.1. And then minimum velocity for rigid duct. Press here, rigid duct. And then run out is here. Maximum velocity for rigid duct. And then run out is for 050. Okay. And then minimum and also maximum height is just ignore. The shape of your main trunk is rectangular. And then the shape of your flexible ducting is round. Maximum CFM per run out is this one is maximum amount airflow rate. Airflow which you want CHP to distribute to each run out in your room in this air system. So 1 to 5 CFM. So for the schedule, this one basically at outside original basically for normal condition all of your ducting size is using nombor genap lah. Okay, so even number. Just press this one, number 1, even number. So 2 inch, 4 inch, just only use the even number only. Alright, so settle duct sizing equipment, just ignore it. Just stop here, duct sizing. So all the parameter you need to input except minimum and maximum height. Okay, next we go to the handle settle. Okay, and then we go to our room data. Okay, basically you need to input all type of room provided on your layout. Okay, basically you have room number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Corridor 1, just use this one as a corridor 1 until here. This one is corridor 2 and also corridor 3. Okay, here. So basically you have 13 area to calculate the cooling load. Okay, so let's say number 1 is meeting room. Okay. Okay, let's say 1 is meeting room. So put here meeting room. So system 1, this one is AHU number 1, which you have setting from previous point, which is a handle lah, AHU number 1. Zone compulsory to put 1. And the length of your meeting room, you just refer your table. Okay, here. Room 1, meeting room. So the mention length is 18 feet. Width is 8 feet. So length is 18, just put 18. And width it is 8 feet. So height is ceiling height. This one is ceiling height. So ceiling height is 8. 8 ceiling height. Okay, ceiling 8 feet. And just leave it 1 here. Check error is yes. So basically this software will do the automatic error for you. Okay. So okay, we stop here. You continue after this. Stop here, okay.